Good evening, everyone. Switch on your cams. Let's start off. Chalo, cams on, everyone. Next week, a test is online. You guys can give it. I'll be posting in the group. The test will be on thermal expansion, KTG, and calorimetry. Chalo, cams on, everyone. Where are the rest? Hmm. Okay, today we'll be starting with a new chapter, fluid mechanics. Properties of matter. Technically, it has again 4 parts. One is fluid statics and dynamics, viscosity, surface tension, and elasticity. It's a decent one. Fluid mechanics kind of looks like laws of motion again, right? FBDs and all that stuff will be there. So let's start it off. Ideal fluid. What's an ideal fluid? Any substance that cannot withstand tangential force. Technically, it's called shearing stress. That's a more technical word, but let's keep it simple. Tangential force. What do you mean by that exactly? Let's say we have books. Others, you need to keep your cams on. And let's say if you apply force on this, this is what we observe. The books will start sliding on top of each other. Something of this sort. So whenever you apply force here, so on this book there is a friction. On this book there is a friction. Friction and so on. So basically, there is a friction opposes the tangential motion of the books. Right? Suppose if you have books without friction, this is stack of books with friction. If friction is absent, this is what you will see. The force which you applied on that one book, only that one book will move. No? Not only that one book, anywhere you apply the force, only that book will move. Make sense? So when force is applied, only that layer will move. Which force is applied moves. Basically, there is no opposition to the motion of the books. There is no opposition to tangential force. Whereas in the above case, if you see, there is an opposition. There is some kind of resistance. So basically, you can think of like this, whenever you talk about a fluid is nothing but, it is like layers. Studied in chemistry, remember graphite? Graphite is actually layer upon layer. There's a very weak bonding between each layer. That's why graphite acts like a good, lubricant, because the layers can slide on top of another. So something similar happens in fluids also. Whenever you talk about a fluid, it is not a single substance. It's like, they form layers. And whenever you try to apply a tangential force, it starts sliding off. So if you take an ideal fluid, right, and if you try to apply force, this is what happens. Let's say you have a container. And let's say you apply force F at an angle theta. So we can resolve this into two components, F cos theta and F sin theta. Now, what does this F cos theta do? This horizontal component, because just now I said, right, the liquid cannot withstand tangential force. F cos theta pushes the liquid. Changing its shape. Right? The liquid will keep moving till the force becomes perpendicular to the surface. This is a simple thing, but quite a useful one. So this is what happens after some time. The liquid will keep moving till this force here, F, becomes perpendicular to the surface. You're getting the logic there? See, liquid does not have a problem with compression. If you push the liquid, it's like, when you take these books, if you push the books like this, is there any problem? Books don't have a problem when you're compressing them. The moment you try to apply a horizontal force, the book starts sliding. Same thing similar happens here. If you try to apply a force at an angle, the liquid will keep moving till it becomes perpendicular to the surface. Clear with this? So it is always that way. If it is not perpendicular, then what will happen? The F cos theta will move the liquid till it becomes equal. I'll give you a crude example. Think of like this. Let's say in your room, it is filled with, a lot of that plastic balls or something. Let's say every second, imagine you're throwing 100 balls per second this way. After some time, what will happen? The balls will start piling up like this, right? They'll start coming at an angle. Now, some of the balls will start coming down also. So let's say you're throwing up 100 and let's say 20 are coming down. What will happen? This will become even more steep. Let's say you're throwing 100 and let's say 50 are coming back. It will still become more steep. Let's say you're throwing 100 and 100 are coming back. What will happen? You will reach an equilibrium. Able to visualize what I was saying? So this gives us a very important statement. The net force acting on a the net force on the surface of a fluid is always perpendicular to the surface. Important thing, whenever you calculate the net force with respect to the container. Meaning you have to include the pseudo force if the container accelerates. That is include pseudo force. Container accelerates. There, please have a look at this page. This thing, what I wrote in red, is the most important thing. This is a property of the fluid. Whenever you apply force, it cannot withstand tangential force. So the liquid will keep moving until the force becomes perpendicular to the surface. Clear? Let me take some examples. Let's say we have a container here filled with liquid. Container is at rest. Now, we are looking at a molecule on the, some particles on the liquid surface. What is the force acting on this surface? mg. That is the only force acting on the surface. So the surface has to be perpendicular. Therefore, the liquid remains flat. That's an easy example. Suppose the same container is on an incline at rest. Now, if I put liquid in this, how will it look? Like this now. The force is still vertical mg. The surface will still look like this. Isn't it? It won't be parallel to incline. Why will it be parallel to incline? The container is at rest, right? The only force acting on the liquid surface is mg. Suppose if you have a smooth incline and you put a container, and let's say container itself is going with g sine theta. So container is sliding. And now if you put liquid inside, then how does it look? How do we do this thing? Listen, I'll show you this. We're going to do a problem on this. So we have an observer on the container. So if you ask him to draw an FBD, again, remember we are drawing FBD of liquid surface. So first thing, mg sine theta, mg cos theta. Since the container is accelerating, we'll get a pseudo force ma, which is nothing but mg sine theta only, which is the pseudo force. Therefore, the net force would be mg cos theta. So the liquid surface will think the net force is mg cos theta. It should be perpendicular to this. So this is your net force mg cos theta. Liquid surface will be like this. It will be parallel to incline. Making sense? Logically, now if you think about it, socho kya ho raha hai? The container is going with g sine theta. Liquid is also going with g sine theta. So you're not giving a chance for this liquid to hit the container and accumulate, isn't it? Every time it tries to go forward, container is also going forward. No? If the container was at rest, This liquid would have come here, hit this wall here, and would have got accumulated, and that's why it was becoming flat. But if the container is also going with the same acceleration as you, it will always remain flat. Please have a look at the three examples. Clear with this? Now remember, I taught you only one concept till now. What is the only one concept? If there's external force acting on the total force acting on the liquid surface should be perpendicular to the surface. Clear? Let's see a question on this. This is theta. Mu is less than tan theta. Angle of repose, meaning the container would slide. Now in this we have liquid. Find the angle made by the liquid with respect to the horizontal. Same as example 3, but this time it is not, acceleration won't be g sine theta. Find angle made by liquid surface with horizontal. Let's get this. Answer comes in terms of theta and mu. Little, I'll help you out a bit. Only difference will be, this will be how much g sine theta minus mu g cos theta, na? Remember, if a block slides on a rough incline, acceleration is what? Mg sine theta minus friction is ma. Friction is mu mg cos theta. That's it. This is the only difference. So this will change here. Tan inverse sine. No, Arjun, that's wrong. I want with the horizontal, everyone. Meaning, if this is the surface, I want you to find me the angle with this, with the ground, not with the incline. Try, everyone try. You got a minute. Yeah, Anika, that's not right. Cos inverse. What is A here, Aryan? You're creating new variables. A is not given. No, answer is wrong. Any answers, do type in the chat box here to the co-host. See. First thing, you'll have mg sine theta, mg cos theta. So this blue line which we have, theta, this is your incline. This is your pseudo force MA, which is mg sine theta minus mu mg cos theta. So the resultant will be mu mg cos theta, mg cos theta. This would be your net force. Your liquid surface should be perpendicular to this black line. Where this angle is 90 degrees. Liquid surface and F should be 90. Let this angle be alpha. So I want to find alpha basically. I hope everyone is getting the diagram there. Okay. And if I take this angle to be beta, tan beta will be opposite side mg cos theta by mu mg cos theta, which is 1 by mu. If you complete this triangle here, if that is beta, this would be 90 minus beta, and this would be 180 minus theta. The sum of the angle should be alpha plus 90 minus beta plus 180 minus theta should be 180. 180, 180 cancels off. This would be theta plus beta minus 90. Check it out. You could have taken this angle also as beta. You would have got something similar. In that case, you will get alpha plus beta plus 180 minus theta. Depends on what you're choosing as beta. Beta is tan inverse mu. Tan beta is 1 by mu. So alpha is theta. Tan 90 minus beta will be cot beta, no? So this would be theta minus tan inverse mu. How did I get the pseudo force? What is the acceleration of the container? God. How then? If a block is placed on an incline, what is the acceleration?
G sin theta and G cos theta.
G sine theta minus mu G cos theta. So what is pseudo force? M into A in the opposite direction. No? Check your answer, everyone. If this angles were looking confusing, I can do one thing. Let me just change that beta ka thing only. I can choose this angle as beta. Then this would be 90 minus beta, and this would be beta. This would be 180 minus theta. So tan beta would be mu mg cos theta by mg cos theta. Alpha plus beta plus 180 minus theta is 180. So alpha is theta minus beta, which is theta minus tan inverse mu. Same thing, doesn't matter which one you take. All got this? And think about it, na? Suppose if I take mu is equal to 0, I'll get alpha is theta. It is parallel to incline. There's nothing there. It is just to draw an FBD and then geometry. That's what I said. This chapter looks like NLM. Clear with this? Let's see one more. Any doubts? Anyone didn't understand any particular thing? I'm just worried about the diagram. It's little. I hope it is clear, but so. Better. Clear? Next question. And I taught you only one concept till now. You can do pretty good questions on this. So we have a cube, which is half filled. The upper part is open top. This is L by 2. This is L. This is L. This is L. So side of the cube is L. Content is accelerating with A. Draw the shape of the liquid. And the amount of liquid spilled outside. First case, acceleration is equal to g by root 3. Second case, if A is equal to g. Third case, if A is equal to g root 3. Three different questions. If the container accelerates with g by root 3, draw the shape and find the amount of liquid that, that spills out. B, if A is equal to g and A is equal to g root 3. Three different cases. Hope the question is clear. So there, this is how it looks. Must have seen, right? These water tankers. Now, see, the tank is just going with constant velocity. There's no problem. Water will be flat, but suddenly if you stop, can you see how the water accumulated? So when you're applying brakes, right, the acceleration will be backward and the pseudo force will be forward. And so how the water accumulated on the front side? The water ka surface ka shape will change. You can see the entire water has gone to the right side. The truck has stopped, so water will keep sloshing. That's what I was saying. The water will not be flat. So our question is something similar, but yeah, we have a constant acceleration. How do we do that? Take a minute, then I'll show you. Okay. L cube by 2 root 3. What is that, Lakshika? Volume spilled? That is wrong. See. So when the truck is accelerating with A, if you look at the forces, we have the pseudo force Ma, and we have the weight mg. So the resultant force will be something like this. And the liquid surface should be perpendicular to the F net. Meaning all that liquid, right, would be something like this. If you take this angle as theta, this will be theta and this will be theta. So from here, we clearly get tan theta is equal to Ma by mg. This is a standard result. Tan theta is A by g. So whenever the container accelerates, the liquid inside will make an angle of tan theta is equal to A by g. Now, using this condition, the first one, when A is equal to g by root 3, we get tan theta is equal to 1 by root 3, which is 30 degrees. Meaning the liquid will be like this. This will make an angle of 30 degrees. And if you see, the liquid will not overflow. There's no spillage. Now, in the exam, they can ask you this question also. They can ask you, find the difference in height, H1 and H2, or find H1, H2. How will you find that? Anyone? Can you find H1, H2? The B part, when you have A is equal to G, the container would exactly be on the edge. This would be 45. Here also there is no spillage. How to find H1, H2? C is interesting. A is G root 3, theta comes 60 degrees. But here, if you observe at 45, it can't exceed than this. So there's only one possibility. You can't change the height, so you will change the base. So this would be L. This would be L by root 3. You're accelerating so much, the container actually gets exposed to atmosphere at the bottom. This would be 60 degrees. You're getting it? This part of the container is exposed to atmosphere. There's no liquid here. And how much will spill here? Volume spilled will be initial volume, which is L cube by 2, minus, this is a triangle. If you see in three-dimensional, this actually kind of looks like this. It's like a triangle with a width. So half into area of a triangle, L into L by root 3 into L. That is how much liquid will spill out. Initial volume minus final volume. Here, how to find H1 minus H2? Tan 30 is H2 minus H1 by L. That is one equation. Next thing, volume is conserved. Volume is initially L cube by 2, should be equal to half area of this trapezium, which is H1 plus H2 into L square. Two equations, two unknowns. From here, you can find H1 and H2. Check it out. You can conserve volume and you can write tan theta is the opposite side, the difference by the base. So this is the first thing. So tan theta is equal to A by G. This is a kind of a standard result. Bits or CET level question this is. Especially people get confused with the C part. They don't understand how to draw 60 degrees because exactly at 45, you're already covering like this. So it doesn't click like, you can have a surface like this where this part is exposed to atmosphere. That is, people get confused. They're like, how can it be? Because you can't change the height, but you change the base. Do have a look at this question. Any doubts on this? Anyone not convinced with this, please ask. Again, I didn't teach you anything, only one concept. Net force should be perpendicular to the surface. Arjun, clear with this?
Yes, sir.
Ali? Clear? Neil? Anika? Got this? Palaksh? Rehan? Yasha? Swastika? Clear, na? Partika? Got it? Can I go ahead? Next one? Anyone not convinced with anything particular, please ask. Next one. Next one is even better. It will be a good advanced paragraph question. We have a cylindrical container. So initially you have some water. This is height h. This is the radius r. Height of the container is capital H. And this thing starts rotating with omega. And you must have seen this in your house now when you put water in a bucket and rotate, or when you are mixing some milk or something, and when you rotate, you'll get a shape. You get a bowl shape like this. This height is H2. This height is H1. This is the bowl shape. So the first question is, find the equation of this curve. Second question, it's called vortex, whatever you want to call it. Find H1, H2. Third, find the condition if liquid overflows or liquid spills out. Find the condition if the bottom of the container is exposed to atmosphere. Means you're rotating so fast, the bottom will get exposed. Meaning it should become like this. You're getting it? The liquid is rotating so fast, meaning it is exposed. Bottom will look like this. You're getting it? See now, when the liquid is just touching, how will it look? It would kind of look like this. Now, this is the limiting value, isn't it? This is the case where H2 is 0. If you rotate even faster, what will happen? This will rise here. It will become like this. So basically, you'll get an opening there. You'll see if the bottom is exposed. You have to get, if you get B, you'll get everything. First, get the equation and B part. A and B are the main questions. C and D are just variations of question B. Bottom is exposed, that's it. Spilling or not spilling is not mentioned. So you can have a condition like that also, Rehan. You can combine both. Find the condition if the water spills and the bottom is exposed. Then C and D together hoga. So basically C and D are independent of each other in our question. First find the equation and H1 and H2 everyone. Let's start from there. Find the equation, that is starting. Just give it a try. This is the answer. Equation. Yeah, what kind of equation is that, my God? Why is x square? Without omega, nothing. Alakshika. Listen, let me help you with the first one. So, that bowl shape, whatever you get, consider this point as origin 0, comma 0. So if you consider this point as x, comma y, again, we are drawing FBD of a particle on the liquid surface. What are the forces acting on this? M omega square R. R is x here, centrifugal force. And this is mg. So the net force will be this way. This is your F net. So your tangent should be perpendicular to the net force. Isn't it? This is your 90 degrees. So if you take this angle as theta, this angle will be theta. Therefore, tan theta will be m omega square x by mg. But I know tan theta is nothing but dy by dx, which is omega square x by g. Shift it on both sides and integrate. So dy is omega square x dx by g. So will be y is equal to omega x square by 2g. This is the equation of this. In two-dimensional, this is a parabola. Three-dimensional, this is a paraboloid. So it actually forms a paraboloid shape. So we are choosing the bottommost point as 0, 0 as origin there. Now what? Now you need to find h1, h2. How will you do that? There I got you the equation. Take a minute. There is something which you will need to use. I'm pretty sure you forgot. Calculus. There is this property, if you remember. If you have paraboloid, the volume of a paraboloid is half of the volume of the cylinder it is enclosed. Anyone remembers this? This is the result we derived in calculus. In case you forgot, you need to go back to this and refer. This I taught you for this problem. The proof is here. So you can remember the result. If you have a cylinder of radius r and height h, and inside there's a paraboloid, it will occupy exactly half of the volume of the cylinder. You're going to need this result now. Now try. I'll give you 2 minutes. See. This bowl here. So this here is H2. This here is H1. And you have taken this as origin 0, 0. And this equation, right? Y is equal to omega square x square by 2g. So for this parabola, if you look at this width here, this is R. So here the y will be the height of this thing, which is h1 minus h2 is omega square r square by 2g. This is equation 1. Agreed? The difference in height of the parabola is a y coordinate, which should be equal to omega square r square by 2g. Make sense? Basically, in this paraboloid, this is 0, 0, and this coordinate will be r, h1 minus h2. Next thing, conservation of volume. Initial volume is how much? Pi r square h. First, let's get this volume of this liquid actually. This liquid, right, can be treated as two parts. One is this paraboloid plus that bottom ka cylinder. This height will be this height is h1 minus h2 and this is r. So this is half of pi r square h1 minus h2. And this will be h2, so plus pi r square h2. Volume of paraboloid is half of volume of the cylinder it is enclosed. This you can refer to calculus ka notes, page 121. Then conserve volume. What is initial volume? Pi r square small h, and this would be pi r square by 2 h1 minus h2 plus pi r square h2. Pi r square will cancel and h would be h1 plus h2 by 2. Therefore, h1 plus h2 is 2h. This is your second equation. Two equations, two unknowns. If you add them, you end up with h plus omega square r square by 4g. h2 will be h minus omega square r square by 4g. Please check. Clear, everyone? Next thing. Now question is over, right? You want the condition for it to overflow. To spill H1 must be greater than the height of the container. For bottom floor to be exposed, so H1 is how much? H plus omega square R by 4G must be greater than equal to H. So from here we get omega is greater than equal to 4GH minus H by R square ka root. If you rotate with this omega, you will this thing. For bottom floor to be exposed, H2 must be negative, meaning this is how it would look. The parabola equation which we got, if you had continued, it would have been like this. Meaning H2 is negative. This is H minus omega square R square by 4G is less than 0. And we get omega should be greater than equal to 4GH by R square ka root. There. So they can ask you questions like this. Find the condition if the liquid spills even before the floor is exposed. Find the condition if the floor is exposed before the liquid spills. I can play around multiple things. But the main thing, you need to find H1, H2 first. And especially we have to use this condition here. This volume ka conservation you should know. Please check. It's a pretty good one. Clear with this? Turn in the page. Have a look at this. And all this with just one definition, that the force is perpendicular to the surface. Next thing, going ahead. Any doubts? Anyone not convinced with anything particular? This problem you should definitely try to do it on your own again. Especially you have to integrate and prove this will be half of the volume. Next thing. Whenever we talk about fluid mechanics, right, the important properties are generally density and pressure. Instead of mass, we talk about density. And instead of force, we talk about pressure. Density symbol is rho. We talked about a bit in thermal expansion. So density rho is given by mass by volume. Density of water is 1 gram per cc or 1000 kg per meter cube. You should remember this. Density of ice is 0.9 gram per cc cubic centimeter or 900 kg per meter cube. Density of mercury is 13.6 gram per cc or 13,600. These are some standard values you should remember. Sometimes they'll give you specific gravity. This is nothing but relative density of the material with respect to water. Example, if they say specific gravity of gold. This is almost 19.3. That's it. They'll just say 19.3. The meaning of this is Density of gold is 19.3 times density of water. That is 19,300 kg per meter cube. Gold is pretty dense. And then we have variation of density with temperature. This also we talked about in thermal expansion. The new density is given by rho naught by 1 plus gamma delta T. Gamma is coefficient of volume expansion. Have a look at this page. Reason why we study density instead of mass, because mass of the liquid will depend on the container, whereas the density of the liquid doesn't. Clear? Let's see a small question on this. Two liquids of density rho 1 and rho 2 are mixed. Case 1, you mixed equal volumes of liquid. Case 2, equal masses of liquid. Meaning in the first case, let's say 10 liters of liquid 1 and 10 liters of liquid 2. Second case, में 10 kgs of liquid 2 and 10 kgs of liquid 1 and 2. Find rho average. Find the average density. Others, do keep your cams on. Get it. Easy one. Yeah, that is right, Arjun. Let's see. Rho average is simply total mass by total volume. Rho 1 V, rho 2 V by V plus V. Second case, let the mass be M. The total mass is M plus M. Volume is mass by density. Mass by density. That's your answer. Check. Easy one, but yeah. Next thing. Pressure. So what's pressure exactly? Symbol is P. When a body is immersed in a fluid, the molecules collide with the surface, generating a force along a common normal. This force per unit area is called pressure. Now, if you go back to collisions, let's say if you have some random surface like this, let the molecule collide however it wants. Oblique collisions. The force will be always along the common normal, isn't it? Because the horizontal component, the component perpendicular to normal is unaffected. So no matter how the molecules collide, the force will be always along normal. So basically, these are oblique elastic collisions. That is the reason the force due to pressure is always perpendicular. Actually, it is the reverse way. The statement, right? Force due to pressure is perpendicular is actually wrong. The definition of pressure itself is perpendicular force. Getting it? So, but yeah, you can say the force due to pressure is always perpendicular to the surface. So it doesn't matter. You can take an amoeba shape and put it in a liquid. You can be sure the force is always acting perpendicular to it, perpendicular to the surface. So if you take some random shape here and if you immerse it in a fluid, you can be sure whatever is the force will be perpendicular to the surface. So from here we can define pressure as force perpendicular by surface area. The reason why the force due to the thing is perpendicular is because the collisions will always generate a perpendicular normal force. Please have a look at this picture. So you can actually write like this. The force is pressure into area vector. P is a scalar. Do have a look at this picture. Next thing. So the meaning of this is, if you say at this point pressure is P, so if you take a small area dA1, or if you take a small area dA2, or if you take a small area dA3, so this force will be perpendicular to this guy, F1, F2, which is nothing but P into dA2. This is P into dA1. So the force ka direction will depend on the area vector. The units of pressure are pascals. 1 Pascal is 1 Newton per meter square. 1 atm or atmospheric pressure is 1.01 into 10 power 5 Newton per meter square. We'll take 10 power 5 for simplicity. You can also write this thing in terms of the mercury column ka length. This can be also written as 76 centimeters of Hg column. We will talk about this later on. Sometimes, right, they'll give you something called gauge pressure. This is something which you will see when you go to petrol pump, right, to get your air filled. Gauge pressure is pressure with respect to atmosphere. That is actual pressure. Minus atmospheric pressure. So example, if someone says gauge pressure is 5, the actual pressure is 6. Have a look at this. Clear? Next one. Any doubts on this? Again, so the second formula that I'm teaching you is forces, pressure is force perpendicular by area. That's the second formula that we have. Let's say a question on this. Turn in the page. We have a water jet going with speed u. We have a wall here going with speed v. Let's say, let it be this way, v. Restitution is z. Density is rho. A is the area of cross section. This is the velocity of wall. Find the pressure acting on the wall. We have done something similar like this in variable mass system. Theta is equal to 1. This is u, wall is at rest. Density rho and area A. Find pressure acting on the wall. This especially question B is a very good one. Find pressure on the wall due to the water jet. In the first case, even the wall is moving, the force is hitting head on, and restitution is E. Second question, it is hitting oblique, E is equal to 1. Wall is at rest. In variable mass system, I taught you how to find the force due to water jet. Remember? I'm asking you pressure. Let's get this.
So in the first one, E is given variable, right?
E only.
मतलब like not a value.
Yeah, answer एक terms में आएगा. Now you will observe one thing after rotation, right? Every chapter now will be like, you must have seen something like that. You know, there'll be something, one or two new words, but at least half of the chapter will be mechanics only. Mechanics will keep haunting you till the end. The optional test on mechanics I did extend for 1 more week. So anyone wants to give, it is there. Some of you have requested that you want to give, so I did extend it. Rho, you got an answer without E, Aryan. First thing, see, wall is going with constant velocity, right? Stop the wall. That will make your life easy. Stand on the wall. So with respect to wall, it feels like the water jet is coming with U plus V. After colliding, it bounces back with what speed? E times U plus V. Make sense? So what is change in momentum? Again, we are choosing a small piece here, dx. The mass dm will be density into area into thickness. So change in momentum dp will be 2 times dm final dmv final minus dmv initial. So it is minus of minus. So rho a dx u plus v 1 plus e. This is your change in momentum. Therefore, force is equal to dp by dt, which is rho a dx by dt. Remember here, dx by dt is relative velocity. Because the x is changing because of both the velocity of the wall and this guy. So u plus v into 1 plus e. So therefore, force will be rho a u plus v whole square 1 plus e. Pressure is force by area. Rho u plus v whole square 1 plus e. Check. That's your answer. Change in momentum, it is minus of minus. This v final is minus e u plus v. V initial is u plus v. I skipped the steps. Please check it out.
So I didn't get how dx by dt will be u plus v.
What should it be according to you?
So what did you take dx as? You took it as an element of water in the thing, right?
What is x here? dx is the element of water that is hitting the wall, isn't it?
Yeah. Oh, okay. Now it makes sense. Yeah.
So x is this only now.
Yeah. Yeah.
Clear with this? I hope you remember we did something like this in fluid in this thing, variable mass system. But in that I didn't move the wall. Question is not over. The main question is the B part. Get this one. The water jet is hitting at an angle theta. Wall is at rest. E is equal to 1. Find the pressure acting on the wall. That's the main question. I'm turning back to the question. Any doubts on this page? Yeah. Try. You got 2 minutes for this.
So can you show that one for a minute? Yes, sir.
So you solved it with respect to the wall now. Otherwise, it would have just come out to be u, right? Dx by dt.
Which one?
In this A part, you solved it with
Uh,
respect to the wall. That's why it came out to be u plus v. Otherwise, it would have just been u, right?
Hey, even if you do it with respect to the ground,
Yeah.
when you differentiate, what is x? X is distance between the wall and the water jet.
Acha. Okay. Okay. Got it.
And that is changing because of what? Both of them,
Ah,
right?
then yeah, I understood.
Anika, E is 1 रहे second case में. Second case में E is 1. And sign नहीं आएगा, God. Only the momentum along the normal will change, na? Let's see. लक्ष्य ये नहीं आएगा. And how did you get cos square? That is an interesting thing. See. This is theta. So the momentum will be, this is u. This is also theta. So this is u cos theta. And this is u sin theta. So change in momentum will be 2 times rho a dx, that is a mass, 2 mv cos theta. Agreed? Only the horizontal component changes, vertical component doesn't change. So force will be dp by dt. Till here it is great, huh? Everyone gets it. Now the catch is this. When you say pressure, what is pressure exactly? Pressure is force by area where the force acts. Now see what happens. When this water jet hits the wall,
So you give equal to 1.
E is equal to 1 is given.
Oh, acha, acha, acha. I wrote in terms of
This
E.
area is A, but the water jet is hitting a bigger area. Are you getting this? The water jet spreads. This is theta. This is theta. This will become A by cos theta. The water jet spreads over a larger area. If you look at the side view or the front view, this is how the water jet looks. It's like a circle actually. R and R. After hitting now, what happens? One side will stretch. This is R, but this side has become R by cos theta. You're getting both have not increased. So actually it becomes an elliptical area. Are you getting it? This shaded area actually becomes an ellipse. The water spreads out in one direction, the other side, the width will remain same, but the height will increase. That's why the area becomes A by cos theta, not A by cos square theta also. So pressure is, most people do this mistake here. Force perpendicular by area where the pressure force acts. So pressure is not force by area, it is pressure is force by A by cos theta. The water jet will spread and hit a bigger area. So the pressure becomes 2 rho u square cos square theta. Quite a important result, right? Most people will write cos theta, F by A and come. So be careful with that. Aryan, clear with this? Or you got 4? No, no. Is everyone getting this point why the area spreads? Do have a look at this. All clear with this? Take a break, come back with 7:10. Any doubt so far? Anything you're not clear, please ask.
So how did you get the U square there?
dx by dt na re?
Okay.
Sir,
So,
could you explain that part where you got, I mean, u cos theta, वो तो square होना चाहिए ना? तो 2u cos
क्यों?
theta, सर रो ए v square होता है ना force, तो
Rho a v square होता है, so
सर तो 2u cos theta का square
है
होना चाहिए.
v is not u cos theta रे god. ये देखना 2 rho a dx by dt is u cos theta क्या? dx by dt is still u only ना?
u, या
हाँ, तो क्या आएगा? एक ही cos theta आएगा.
अच्छा समझा.
x ये है ना god.
हाँ, got it.
तो u को you're not replacing u with u cos theta.
उसको dx by dt डाल रहा है ना, मतलब
Yeah.
okay, got it.
हाँ अभिनव clear ना?
so can you go to that A wala part? So over here, how did you get dx by dx?
dt है रे वो.
dt है ना? Yes, sir.
ठीक है, come back with 7:10. Cams on, everyone. Next thing. Variation of pressure. Consider an imaginary cylinder. Inside a liquid. At points A, B, C. So let's say we have a cylinder here. It's an imaginary cylinder there. Let this point be A. Let this point be B. Let this height be HA. Let this height be HP. I will take one more cylinder here and let this be point C. Outside of the pressure is P naught. Now, if you draw the FBD of that cylinder, the forces will be pressure at A into area, pressure at B into area, and the weight of the cylinder is mg. Weight of the cylinder is density, area, the height of the cylinder is hp minus ha into g. If you balance these forces, pb minus pa into area will be rho a hp minus ha into g. So from here we can clearly see pb minus pa is rho hb minus ha into g. You can write this thing as delta P is equal to rho G delta H. This gives you a differential form. So dP, the small change in pressure, will be rho G dH. Where H is the difference in height and dH is a small change in height. This is a change in pressure across dH depth. Now in that formula there, if you take if HA is equal to 0, then pressure at A becomes equal to P naught. Then your formula becomes P is equal to P naught plus rho GH, where H is the depth from the surface. But the only problem with this thing is this is valid only if rho and g are constant. Have a look at this. Clear? Any doubts on this page? Again, if you see, I just drawed FBDs. Huh? If you observe from the beginning, we are doing nothing but drawing FBDs. So don't think of it like a new chapter. Just think of, instead of using force, you're using pressure. Instead of using mass, you're using densities. Now, if you take this horizontal cylinder, this would be PB into area. This would be PC into area. We get PB is equal to PC. So from here, we can make a statement. Pressure varies only in the vertical direction. And remains constant in the horizontal direction. So only pressure depends on depth. In the horizontal direction, it is the same. Now this creates a small issue actually. What is up and down? When you keep saying up and down, exactly what is up and down? The direction of net force is called down. So when you say up and down, what it means is the direction of the net force is treated as down. This should include the pseudo force. Whenever you take the net force, include pseudo force if the system is accelerating. Example, on Earth, what is down? Toward the center of the Earth, isn't it? That way, if you go into a gravity-free space, there is no concept of up and down. So, example, let's say I have a fully filled cylinder, a fully filled sphere. This can be a good question also. Let's say this is point 1, point 2, 3, 4, 5, 6, 7, and 8. This is at rest. Right? I can tell me which point has the highest pressure. So here, what is down? This is down, no? What is horizontal here? These are horizontals, line perpendicular to the down. So which point has the highest pressure here? E5. Then 4 and 6 are equal. Then 3 and 7 are equal. Then 2 and 8 are equal. Then P1. The difference in pressure P5 minus P1 is density, G, depth is 2R. Now the same question. Suppose this guy is accelerating with A is equal to G. Same thing, 45 degrees mein hai everyone. Now can you tell me which point has the highest pressure?
Six.
So this is accelerating, okay? So if you see the pseudo force here, this is MA, this is mg. Now in this case, this would be your down. And mg effective, the net gravity. If you remember, we discussed something like this, in NLM, root over ma square plus mg square. This is a square plus g square. This would be the effective gravity. So everything in the liquid will start thinking gravity is in this direction from 2 to 6 at 45 degrees. And now in this case, this will be down. This will be horizontal. So the highest pressure will be P6 greater than P5 and 7 are equal now. 4 and 8. 3 and 1. And then P2. The difference in pressure P6 minus P2 will be rho G effective, which is G root 2 into 2R. So on this system, second thing, people will think the gravity has become 0 too. Are you getting how the question changes? This is what I mean by net force. Include the pseudo force, find the net force. Now that is your down ka direction. So in that frame, the gravity ka value also changes. It won't be G anymore. It will be 0 2. I to K is equal to G here. In the first case, when it is at rest, only mg is acting. So the net force is vertical, meaning up to down. So this concept of G effective is very important. We are going to use this again in oscillations, the next chapter. We're going to use it in electrostatics. Right? We use this in few places. So G effective is quite a useful concept. Please have a look at this page. So when you say gravity, pressure changes with height. So exactly what is up and down then? Up and down is not what you think. Up and down is the direction of net force. Anyone not convinced with this page, please ask. Clear? Let's see a question. We have a fully filled container. This is L and this is H. The container accelerates horizontally. Gravity is there. This point is A and this point is B. Find PB minus PA. How do we do this? See. So the idea here is, if you consider a cylinder here, let's call this point C. And if you consider one more cylinder here, so pressure varies only in the direction of the acceleration, isn't it? So when you're traveling from A to C, the pseudo force, it looks like, it is A is backward. And if you stand on the frame, the pseudo force will be backward. So you can directly write PC will be PA plus rho, G ka place mein A and L. Just give me a minute. So you can actually treat this like, as if the gravity is acting in the horizontal direction. Or
but
you want, I can, but it is
not acting in the horizontal direction.
It is acting in the horizontal direction. If A is this way, pseudo force will be which way?
So वो ठीक है, but G effect, G जो नीचे लग रहा है उसकी वजह से G effect
उससे क्या
पड़ेगा.
फर्क पड़ेगा? If you're taking length in the horizontal, why will the vertical acceleration matter? You take the length in this thing. Chalo, if you don't like this, I'll show you in another way. PA into area. So this can be written as PC into area minus PA into area is equal to mass into acceleration. This is PA minus PA into area. Mass will be density and area, length, acceleration. We get PC is equal to PA plus rho AL. Getting this? So the system, right? And then when you same thing, draw the FBD from C to B. So when you're traveling in the horizontal direction, vertical acceleration doesn't matter. When you're traveling in the vertical direction, horizontal acceleration doesn't matter. Got it? You would have got the same thing if you do it normally also. This will be PC into area. This will be PB into area. And this would be your MG. So here you will get PB is equal to PC plus rho GH. If you combine these two, you end up with PB minus PA is equal to rho AL plus rho GH. So simply you can assume while you're traveling from A to C to A, C, B, right? You can travel in the along horizontal and along vertical. So when you travel along horizontal, consider only horizontal acceleration. Isn't it obvious? If you're traveling from right to left, why do you bother about vertical acceleration? Mg does not affect this horizontal. Clear? So basically this problem can be treated as if this container has two accelerations. A this way and G this way. So when we travel horizontally, consider only A. When you travel vertically, consider only G. So from A to C, it behaves like gravity is A. From C to B, G effective is B. You can ask me, sir, why didn't you do that here? You could have done here also, you would have got the same answer actually. If you travel like this and if you travel like this, you would get the same answer. You would have got the same answer. Doesn't matter. Because see, I'll tell you the logic. When you say rho GH, G and H are in the same direction, isn't it? What is H? H is the depth in the direction of net force, isn't it? So if you're taking length along small a, G won't matter. So if you get a question like this, so there's no need to do all that. If you want to use net force method, I'll tell you what is the problem. Why don't we take directly, sir? Take directly the length of the cylinder. So do you mean to say net force is along the diagonal? Who told you net force is along the diagonal? When you say MA and MG, what is the guarantee net force is this way? Net force can be like this also, no? Then क्या करोगे? Are you getting my point? There is no guarantee net force is along the diagonal. So you cannot take length from here to here. You will be trapped. Maybe net F net will be like this. Then what will you do? This is safer when you travel in X and Y and just take A and X and Y in that direction. Any doubts on this? Please ask me. It's not tough, but you should know that, that you can do like this. You're not comfortable with that acceleration ka thing? There, I showed you with a regular FBD. Next one. Any doubts on this? This will be a proper mains level question. Next one. We have a vessel here completely filled with water. Density rho. This is R. This is 2R. The height is also R. Outside the atmosphere pressure is P naught. Find force on the base. Find force on the side walls of the container. Side walls meaning if you draw the FBD now, you'll get this side walls. Hope the question is clear. This is a frustrum. Full cone and you cut it off here. Force God, I didn't ask you for pressure, Adrit. Even if it's pressure, it is wrong. Why did you leave P naught? Find the force on the base of the vessel and the force on the side walls of the container. Draw the FBD. First thing, the base is easy. At this point, the pressure will be P naught plus rho GR. Pressure depends only on the depth into pi r square. This is the force on the base. Now, draw FBD of the liquid. So on the top, the atmosphere will push it down P naught into pi 2r whole square, your own weight mg. The base is pushing up with p naught plus rho g r into pi r square. That is a force due to the base. And then the side walls are also pushing. So this side walls is that will be in the vertical direction, force due to the side walls. You can see the symmetry. Side walls are pushing like this, the resultant will be upward. Agreed? So force due to the side walls, I'll write as SW, is mg plus p naught 4 pi r square minus p naught plus rho g r into pi r square. I know everything here. I just need to find m ka value. How will I get m ka value? If you take a full cone, this was 2r and this was 2r. From the full cone, if you subtract this small cone of radius r and height r, then we will get our frustum what we took. Isn't it? So this volume will be 1 by 3 pi 2r whole square into 2r minus 1 by 3 pi r cube. That would be 7 by 3 pi r cube. Therefore, mass m will be rho into 7 by 3 pi r cube. Substitute there, you'll get the answer. You know everything there. Take out the FBD. If you mess up, the FBD question is gone. Entire fluid statics is similar to this. You should, if you can draw the proper FBD, you get the answers. Please check. Anyone confused with the FBD, please ask. Clear? Next one. Any doubts? Anyone not convinced with anything here? Please ask.
Sir,
Hmm.
but forces are acting on a line, we don't have to take that angle.
Which one?
This line walls.
Uh-huh.
So we
How many
can do
forces are there?
side wall, upper pressure, mg and all
Side wall. No. Side wall, if there are two forces, like the resultant किस तरफ होगा?
vertically up.
No. So why do you need angle, right? The horizontal components will cancel anyway. Are you getting F side walls? What did I do? All this net force, na, I wrote it as one force here. I hope everyone was clear with that part. Clear, everyone? Swastika, got this? Neil? Abhinav?
Yes, sir.
Clear? Arjun? Arjun, you're not there. Next one. We have a vessel here. Base area is A. Height is H. Density is rho. Gamma is coefficient of volume expansion. Alpha is coefficient of linear expansion of container. This is for liquid. Outside pressure is P naught. This bottommost point is A. Find the change in pressure when temperature increases by delta T. So if you increase the pressure, if you change the temperature, liquid ka density will change, liquid ka volume will change, container will change, everything gets messed up. Let's get this. What is the answer? It looks dangerous. Actually, it's quite easy. In all this drama, what doesn't change? That's the thing you need to ask yourself. In all this drama, what doesn't change? Density changes, na God. Density changes with temperature, mass. So initially this will be pressure P naught into area. This is mg. So the base ka force will be pressure of A into area. This was the initial pressure. PA is P naught plus mg by A. Agreed? Where m is nothing but density, area, h into g. This is P naught plus rho g h. So if you see only in terms of mass, you will observe clearly. I agree, containers become big. So the area becomes A nu becomes A into 1 plus 2 alpha delta T. But tell me one thing, did the mass change? Mass will still remain same. So what happens is density will change. Look at the mass. Density will become rho naught into 1 plus gamma delta T. Volume will become V into 1 plus gamma delta T. So which actually remains as rho naught V naught only. Density will change, volume will change to keep the mass constant. So this guy will be P naught into the new area. And this will be mg. This will be pressure at A into the new area. So PA dash will be P naught plus mg by A into 1 plus 2 alpha delta T. So P naught plus rho g h by 1 plus 2 alpha delta T. This is your new pressure. So change in pressure will be PA dash minus PA, which is rho g h 1 by 1 plus 2 alpha delta T minus 1. You just need to see in terms of mass, it will be more easy to see. Only the base area will change. So this answer is independent of gamma of the liquid. Do have a look at this thermal expansion and fluid mechanics. Clear with this? Any doubts on this? Next one. Rehan, Palaksh, clear? Vartika? Got this? Yasha, Vidyut? Adrit, clear na? Akshat? Turn in the page. Next one. We have a tall container. Tall meaning it's almost going to infinity. So it is filled with gas. It's an ideal gas. The total temperature of the gas is T, which is constant. So the whole thing is an isothermal process. The pressure at the bottom here is P naught. Molecular weight of the gas is W. Capital M. Find the pressure at a height h. Tall container meaning it goes to infinity. So the pressure at the bottom is P naught. So as you keep going, the pressure decreases. So what is the pressure at a height h? Temperature is constant. This is a gas. So unlike a fluid, right? In case of a fluid, ideal fluid ka density does not change, but gas ka density changes. Give this a try. KTG and fluid mechanics. We couldn't do this in KTG. So the problems which we skipped in Dharmo, we are doing them now. So ideal gas equation, PV is equal to nRT is valid and dP is equal to rho GdH. The differential form of pressure. Answer is in which form? In terms of P naught and H. Whatever variables have given there. What did I give you here? I gave you P naught, I gave you capital M, I gave you T and H. Gravity is there. Gravity is there. So the weight of the gas above this thing is compressing the gas below. So pressure and density both change. For some reason, we're assuming T is constant. Technically, even T changes. So let's not get into that. Show you. First thing, see. PV is nRT. This can be written as P is equal to mass by molecular weight. There is a number of moles. Mass by volume is density. So P is equal to rho by mRT. This is the relation between pressure and density. And we also know dP is equal to minus rho GdH. Why minus? Normally H is the depth from the top. Here we're taking height from the bottom. Since we are going from bottom, from lower to upper surface, dH is negative. Normally in the formula, if you say dH is the depth, so rho is Pm by RT. Take it and substitute here. So dP PmgdH by RT. So dP by P is equal to minus mg dH by RT. Integrate. When the height is 0, pressure is P naught. It is given P and H. This will be ln P by P naught minus mgh by RT. The pressure P will be P naught into e to the power of minus mgh by RT. Check. So this pressure actually varies exponentially. As you go to infinity, pressure becomes 0. Do have a look at this. In case you forgot this minus sign, you got a plus. It doesn't make sense. So here pressure actually decreases with the height. So you can say like that also minus ka reason. Please check it out. We use an ideal gas equation and we use the differential form of pressure. So if you want to guess from the options, that's what you thought about it. T0 should give you, H0 should give you P naught. H infinity should have given you 0. That is the meaning of a tall container. Clear? Next one. Any doubts on this? If you see the questions, right, these things, getting an idea is difficult. Once you get the idea, it is just a matter of solving. And trust me one thing, if you're thinking like, sir, exam mein aisa ideas kaisa aayega, that is the reason you need to practice. You should see different models. I mean, after doing so many different models also, right, what happens in advance, if there are 20 questions, you should have at least seen 14 to 15 questions before only. Something similar. There'll be 4 or 5 unique questions, where you need to actually use your head. So most people have this misconception, right? Advance mein main sab sochta hu exam mein jaake. It doesn't work that way. If you go to the exam and start thinking about each and every question, it will take 10 to 15 minutes per question. You will just do 5 to 6 questions in the exam. That's of no use. You should have practiced enough different models. So even in advanced exam, they're not going to ask you anything out of the world. Like I'm saying, 75% of the paper will be something similar you have seen somewhere. That could be the class notes, that could be the exams, that could be practice papers, anything that you have done. Last one for the day. Let's say we have a liquid here. Outside is P naught. You immersed a disk inside. Half disk of radius r. Density of the liquid is rho. So as you're going down, the depth density increases. Half disk is just immersed in the liquid as shown. That means on the disk at each point, the pressure is different. Find the force due to the liquid on one side of the disk. Both the sides it will cancel out. On one face of the disk. Did you get the question what I'm asking? I could have asked you like this also. So let's say someone makes a container like this, an half cylinder. And this entire thing is filled with liquid. So then find the force on this half disc due to the liquid in the container. Able to visualize? I could have asked the same question. It's the same thing. So as you go down, the pressure is P naught plus rho gx. So every point is having a different pressure. Area is changing, pressure is changing. You have to integrate. Try. You got 2-3 minutes. The answer is pretty cool though. How do we do this? Let me show you. There's no need to actually integrate the whole thing. We have someone who comes and helps us out. So half disk, set a depth y, take a thin strip. Let dA be the area of the strip. You could have taken x dx and solved it, but like I said, there is a much faster way. And at this point, the pressure will be P naught plus rho g y. So force on this one strip will be P naught plus rho g y into dA. So force on the half disk will be integral of force on the strips. That would be P naught into integral dA plus rho g integral y dA. Now this guy is P naught into half disk area is pi r square by 2 plus rho g integral y dA. Now let that then sink in. Y center of mass का formula is what? Integral y dm by integral dm. So dm can be written as sigma, that is mass per unit area, into dA by integral sigma dA. So y center of mass, sigma will cancel off. We get integral y dA by integral dA. So integral y dA is nothing but the total area pi r square by 2 into y center of mass. So if I just substitute this thing here, you end up with P naught plus rho g y center of mass into pi r square by 2. The answer comes force on the half disk. You just need to find the pressure at center of mass into area of the disk. In our case, what is the center of mass of half disk? Anyone remembers? 4r by 3 pi. You can do this for any shape. So I'll just show it to you. That means you can generalize this result. So if I give you any random shape, and if you immerse this in a liquid, and for this shape, it is center of mass is here. So the force on this sheet, okay, this is only valid for sheets. This pressure at center of mass. Find its center of mass into area of the sheet. This works when pressure is constant or linear function. Linear function meaning rho gx. That is the limitation of this. But it's a pretty cool result. There, your center of mass is back. What? You guys thought center of mass nahi aayega? I showed you thermodynamics, center of mass, NLM, everything is there. There is even a better version of this, which we'll see in the next class. I hope you're getting it. Questions were not really out of the world, right? But they're a little different. Thoda, you need to get used to them. So we have done almost, I think, 10 problems. So make sure to go through them once, right? Next class, when we continue, we'll go from here. We will do more questions on pressure and stuff. Okay. So with this, we'll wrap up for the day. And the next week test is online. It's already online there. It will be available till next Thursday. So do make sure to give it. So any doubts, anything you can stay back and ask, also free to leave. So take care, stay safe. I'll see you again next Wednesday.
Bye, sir.